Hi there. This video describes how BACnet devices, operator workstations, and digital sensors are physically wired together in a typical reliable controls system. Connections between components of a reliable controls system are made using one of these physical network types. Ethernet is used to connect higher-level controllers and workstations to each other, and to connect reliable controls systems between buildings and to the Internet. EIA 485 is used to connect smaller controllers to each other and to the higher level or host controllers. EIA 485 is also used to connect Mach Pro point expansion cards to controllers. EIA 232 is used mainly for connecting a workstation temporarily to a controller, for initial setup or for troubleshooting. These first three network types are worldwide standards used by various building trades and well understood by electricians. SmartNet is unique to reliable controls and is used for communication between reliable controls system controllers and reliable controls line of smart sensors. EIA 485 and Ethernet are both very important network types in a reliable controls system because they are used for communication between controllers. EIA 485 is a twisted and shielded pair of conductors run as a daisy chain to multiple controllers. It's important to note that the wire type used for EIA 485 is critical. Reliable controls dealers use a purpose-built EIA 485 wire with low capacitance and impedance as required to maximize bandwidth. EIA 485 is used by various other technologies commonly used in buildings, including security, fire alarms, and lighting systems. EIA 485 is used extensively in reliable controls systems between controllers because a single daisy chain can connect up to 126 controllers and extend up to 1,219 meters or 4,000 feet. EIA 485 is not used to connect operator workstations. One downside of EIA 485 networks is that when the daisy chain is broken, a substantial number of controllers can drop offline, unable to communicate to other controllers or operator workstations. The good news is, each reliable control system controller has a standalone program on board that maintains a fail-safe sequence of operation until communication is restored. Nowadays, every building has some form of Ethernet local area network for occupants to communicate to each other and to access the Internet. Some reliable controls system installations use that same LAN for BAS communications. In other buildings, a completely isolated Ethernet network is installed for the BAS. Many physical Ethernet forms can be combined in a reliable controls system. For example, controllers are available that can use hardwired, power over Ethernet, or wireless connections while communicating on the same network segment. Ethernet is more expensive to install than EIA 485, and single runs are limited to 100 meters or 328 feet. Nevertheless, Ethernet allows communication at a much faster rate than EIA 485, meaning that it has more bandwidth and is capable of transmitting more data in less time. Also, for a reliable control system to connect to the Internet, Ethernet must be used. In a typical reliable controls system, controllers that host other controllers, or have access to the Internet, or have a large requirement for data transmission will have an Ethernet connection. Despite the greater installed cost of Ethernet and shorter distance limitation, its many advantages mean that more and more controllers will use Ethernet communications in the future. The Mach Pro, Mach Pro Web, and Mach Pro View router series of controllers are capable of hosting EIA 485 subnetworks of controllers. Subnetworks always use EIA 485 and can include up to 126 controllers. Typically, subnetworks are used for smaller controllers such as the Mach Pro Air, Mach Pro Zone, Mach Pro One, and SmartSpace controller. Third-party BACnet devices with EIA 485 ports, such as variable frequency drives or packaged heat pumps, also often connect to a subnetwork. To send or receive information to a controller on a subnetwork, the communication must be routed through the host controller to its subnetwork. So controllers that host subnetworks are very critical and really should be connected to Ethernet due to the increased volume of network traffic to the rest of the reliable controls system. If at least one controller on a reliable control system is connected to Ethernet, it's possible to connect the system to the Internet. An Internet connection allows operators to monitor and control the reliable control system from off-site using a remote workstation or mobile device. In addition, an internet connection enables email alarms to remote operators, time synchronization of the reliable controls system from internet time servers, weather updates from weather services that can be incorporated into building sequences of operation, and more. Connecting to the internet means connecting to an IP router that has an IP address on the internet, and may also involve making changes to the internal router configuration. This is clearly a job for an IT specialist, from within your organization or from a Reliable Controls authorized dealer. To protect your Reliable Controls system from security breaches, the use of RC remote access software is highly recommended whenever making an internet connection. EIA 232 is used in Reliable Controls systems to temporarily connect to a controller, usually for initial setup or troubleshooting procedures. To make this connection, a direct connect cable from Reliable Controls is used to connect a computer USB or serial port to the PC modem port of a controller. Not all controllers are supplied with a PC modem port, therefore an export to converter is available to convert EIA 232 to EIA 485, allowing connection to a controller through its RJ11 SmartNet port or a CC Multi-XP2 cable. SmartNet is a proprietary protocol used for digital communication between smart sensors and controllers manufactured by Reliable Controls. Smart sensors are mainly used in wall-mounted applications for monitoring room comfort conditions such as temperature, humidity, motion, and CO2. These devices are described in the next video of this series. The SmartNet protocol requires a 4-conductor daisy-chained bus running between the host controller and one or more smart sensors. The maximum daisy chain length is 45 meters or 150 feet. So an SNX or SSX splitter amplifier device is often installed to boost the total distance. Wire type is not as critical for SmartNet due to the short distances and baud rate, and Reliable Controls recommends using Category 3 or 5 24 AWG solid core wire. Thanks for watching. Let us know if you found this video helpful by clicking the thumbs up or thumbs down. You can send additional comments if you like, and close the feedback window to return here and launch the next video.